Here we go, another video. This one's on hypothesis testing some means when the population standard deviation is unknown. And I'm going to show you how to do this in the calculator. Super quick, super efficient. Alrighty, folks. So, similar to confidence intervals, we know that when the population standard deviation is unknown, we should use the t-distribution. So when it comes to hypothesis testing, that means that we should use something that is referred to as a t-test. How do I find where Ttest is? Well, I hit my stat button, go to the test menu, and right there, number 2 is the Ttest. Okay. Your input option will either be data or stats. Data means that you have the data values in a list somewhere. Stats means that you have just what I call the summary statistics. Okay. Let's try an example, I believe. All right, so in a factory, a machine is supposed to assemble widget parts so that there is less than a 0.2 millimeter offset between each half of the widget. A technician randomly selects 10 widgets and records the offset in each one. The results are given below. Assume that the offsets are normally distributed. Okay. Why do we have to assume normal distribution? Because, I should probably do this first, the conditions necessary for a t-test, so let's do this, conditions for a t-test has to be, well, it's the same conditions that we discussed in the last video. Our sample size has to either be greater than or equal to 30, or we need to know that the population is normally distributed. So that's why you see for this problem, our sample size, we only have 10 widgets, so we need to assume a normal distribution, and that's what they tell us there. Okay, so here we are going to perform a hypothesis test to determine, we are to test whether the average offset of the widget halves is different than 0.2. We are testing if the mean offset is different than 0.2. So what does that mean? That means that our hypothesis, our claim, is that mu does not equal 0.2. This is our claim, which happens to be an alternative hypothesis. Your H null, on the other hand, will be that the mean equals 0.2. All right. Why do we do a t-test here? Because we do not know the population standard deviation. Nowhere in the problem they give us a population standard deviation. Therefore, we must perform a t-test. But we have the data values, so our first step is actually to put the data values into L1. And here we go. Let me get out of this. I'm going to hit second mode. Is how you get back to the home screen. If I hit stat, edit, I'm going to clear out my L1 here. So go up to the top, clear, enter. And I jotted down I wrote down the value, so it was a 0.3, 0.27, so on and so forth. Feel free to pause the video and or go back to where we had the data set. 0.19, 0.18. I think there was 3 of those 0.18s. What's next? 19. 0.29. Okay, I believe I have all the data values correctly entered. I hope so. All right, there we go. We got to perform a t-test. You hit your stat button. You go to tests. And we're going to do a t-test as number 2. All right, this time we have the data. Mu null, mu naught, whatever you want to call it. Mu naught comes from the hypothesis. Our mu naught is a 0.2. That is called the hypothesized mean. We are comparing this to 0.2, so that's what we put here. Our list is L1. That's where our data values lie. The frequency will always be 1. Don't change that. And next we have to determine what type of test are we performing. Is this a two-tail, left tail, or right tail test? This is a two-tail test because the the alternative hypothesis is not equals to. So it's a two-tailed test. So two-tailed test, we go to the not equals option, we go to calculate. And if you're asked to write down your test statistic, so here our test statistic is going to be a t-value or a t-score because we use the t-distribution. So that would be a 1.527 if you went to 3 decimal places. But right now I only care about the p-value, which is a 0.161. So our p-value is a 0.161. All right, and let's go ahead and make a decision and an interpretation. They told us alpha was a 0.05. So to figure out our decision, we take our p-value, compare it to our alpha, and we notice that 0.161 or 161 is greater than 50. Therefore, we're in a scenario where the p-value is greater than alpha. When the p is greater than alpha, that means that we should fail to reject the null hypothesis, which means our interpretation is, because we're failing to reject, there is not enough evidence to support the claim. Okay, so this means, hey, there is not enough evidence to say that the mean offset is different than 0.2 millimeters. So in closing, when it comes to the t-test, that's a scenario whenever you do not know the population standard deviation. Catch you in the next video.